In this Excel project, you are analyzing using the Capm framework, try to get the beta for this company stock. This company is GE, which is a General Electric. Okay, so you are going to estimate the beta using three different methods. Okay, and all of them count as part of your grade. This is your data. The data for the first two columns are the point of a Standard Poor 500. This is the indicator of the stock market in the United States. Okay, and the points here are the weighted average of best 500 blue chip stocks floating in the U.S. market. Okay, and this is the dollar price of GE stock. Okay, and they all change. These are all monthly prices for the market and for the individual stock. And then we have a monthly rate for the treasury bill, 3 month treasury bill, and this rate are in percentage. So 0.09 is not 9%, it's a 0.09%. Okay, so you need to estimate the beta. The first thing is to get the market risk premium and also the individual stock premium. Okay, so how do we do that? The first thing is we have to get the returns instead of using prices. So I'm going to replicate this three names right here. So I select them all, Control C. Control C is for copy, and then Control V is for paste. Okay, and I'm going to get the returns for all of them. Okay, so get the returns for all of them. So for a Standard Poor 500, for the first month, you cannot get this return because you need to have a February's data to get a third February's price to get March return, which is impossible. So you can only start in April. So how do you get return for April? You are going to use the April's price minus the price in March, okay, and then divided by the price in March. This is the required knowledge. You should know this formula, okay? So that's how you get to the return. That's a in the percentage format. That's a 3.60% for the market, okay, represented by Standard Poor 500. All right, and then I just simply double click the right bottom corner, and then I got the monthly return for the U.S. stock market for the rest of the month. Okay, and then for the General Electric, I do the same thing. I just drag it to the right. Okay, you will see the formulas will be applied for a different column. Okay, the new price, the later price minus the earlier price, the difference divided by the earlier price, and then I just drag it or double click, so I have the returns for all the next months. Okay, and then for the T-bill is a different story. So this is downloaded from the Federal Reserve Bank website, and you need to do a little bit of conversion because right here this is a 0.06. If you convert it to a percentage format, it will give you 6%. So this is what I want you to do. You want to divide the given data, okay, given number by 100. Then you have this numerical format. You want to change it to a percentage, increase decimal, and you get a 0.06%. So that's the real number you should have. Okay. All right. So after you get all the raw returns, and then you will get excess returns. Okay, the excess return you need to get for a Standard Poor 500, and you also need to get for the General Electric. Okay, for Standard Poor 500, it is a raw return minus this T-bill's return or risk-free rate. Okay, because let me just delete the extra column. Okay, and then double click. So I will have all this excess return for the market, and then I just drag it to the right, and then I have this is wrong. I cannot drag it. So for General Electric, I use is a raw return minus the risk-free return to get the excess return. Okay, or you can also call it risk premium for the stock or risk premium for the market. And then I just double click to replicate it. All right, so you have the excess return here in the framework of Capm. In the framework of Capm, you should know that it is the individual stock return on the left of the equation, and then the market return on the right of the equation. Okay, so now let me just plug them in. Okay, I'm going to select both columns. Okay, I hit Shift so I can select all of them. Okay, and then I go Insert, and then I go chart, and the first chart is right here. Okay, so this is my chart, and as you can see, each blue point, a blue dot, is a data point, okay, for a particular month. So this is 1 month data, this is another month's data, so you have a roughly 60 months, and that's 60 points on your data. Okay, and you want to make sure that the data is selected as the way you want it to be. So the X value would be the in H column, so that basically is your market, and the Y value is the stock value. Okay, this is the stock excess return. Okay, which is in column I. Okay, this is in column I. Although the chart covers the data area, I can still see which column is highlighted. Okay, and then after I have plugged it in all the data points on the chart, then I just right click on any one of the data points. Be careful, it's a right click, not left click, right click. And then it says add trend line. And add trend line will give you the best fit. I choose the linear, okay? I choose linear, all right? That will give you the best fit line whose distance to all the points are minimized. Okay, so you see each data point has a certain distance to the best fit line, and this line happens to be the one that get close to all of the data points in sum. All right, and then I just right click on the line. Okay, let's say right click on the line. Let's say format trend line, and I want you guys to display equation on chart. Highlight this part. Okay, so let me repeat what I did. So I want you to right click on the line. You see format trend line, and you will see a display equation on chart. Make sure this is highlighted. Okay. Oops. So right click on it, format trend line, display equation on chart. Okay, and then close it. So this is the equation on the chart, and this value negative 0.4207 is your beta. Okay, that's your beta, and you also have a 0.0036. That's the intercept term. That's neglectable. You can also call it alpha. So basically you're done with the first method. It asks you to create a chart from the data and get the slope of the best fit line. The slope is negative 0.04207. Okay, and that's the first method. The second method is actually much easier. Okay, it's much easier. You just use the slope function of Excel. Use a slope, right? And then you select the y's would be the stock axis return, and then comma, and the axis would be the Standard & Poor's 500, the market, okay, and then you hit enter. That's it. So that's another way to get your beta. This is the easiest way, actually. Okay. The third way is to conduct regression analysis, as it says in the instruction. Conduct regression analysis to find the beta. You will find the same number, but this time you're gonna use a data analysis tool. So what you need to do first is to check data if a data analysis package is installed. Right here, I do not have it installed, so I'm going to install the tool package first. I'm going to hit File and then Options, okay? And then I have add-ins. I click on that. Oops. My computer got stuck. All right. And then you see add-ins. You see this Go button. Click on it. And then you see Analysis 2-pack. Make sure this is checked. Okay. Hit OK. And now you see this data analysis being added there. It's under the Data tab. All right. So I click on that, and I want to choose regression analysis. Okay, I want to choose regression analysis. So the Y's would be the excess return for the individual stock, and the X's would be the excess return for the stock market. Okay, and then that's it. I just hit OK. And then it comes with another spreadsheet. This tells me the intercept and the x variables coefficient. So this negative 0.42742, okay, is your beta. And it also tells you about its standard deviation and the t-statistics and the p-value. So the p-value, when p-value is higher, basically means this value is not statistically different from 0. When this p-value is lower, you can see that is more statistically different from 0. All right, so that's the 3 different ways to get the stock beta, okay, within the capital assets pricing model.